Fake news is a serious problem. It is false information spread on purpose to change what people think. Social media allows fake news to go viral quickly. Fake news often spreads faster than real news because it is more sensational. It can damage reputations, incite violence, and interfere with elections. For example, fake news about a political candidate can sway voters. These stories might make false claims about the candidate's policies or personal life. This can lead to people voting based on lies and misinformation. The volume of online information makes it impossible to combat fake news manually. Traditional fact-checking methods are not scalable. We need automated systems to identify and flag false information. Developers are creating AI software to detect fake news. AI can spot common characteristics of fake news, like sensationalized headlines. These systems can track how information spreads online. By analyzing shares and likes, AI can identify artificially amplified content. This helps flag potentially false information for further investigation. Automated detection systems must be developed responsibly. We need to balance stopping harmful content and protecting free speech. Not all false information is malicious. Some are genuine mistakes or satire. Detection systems must differentiate between intentional disinformation and less harmful false information. Data privacy is also crucial. Fake news detection involves analyzing large data sets of user information. This data must be handled responsibly to avoid infringing on privacy. Developers need to build transparent and accountable systems. We need a clear understanding of what fake news is. Fake news is deliberately fabricated or misleading information presented as genuine news. It is designed to deceive and manipulate for political, ideological, or financial gain. This is different from misinformation, which is unintentionally false, and malinformation, which is genuine information used to cause harm. The intent behind fake news is key. Fake news creators exploit our biases and beliefs. By tapping into emotions, they make their content more persuasive and shareable. We are more likely to believe information that confirms our worldview. Fake news creators use various tactics to make their content appear credible. They mimic the style and format of legitimate news sources. Fake news websites use similar names and logos to real news organizations. They may copy the layout and design of legitimate news websites. Another tactic is using emotionally charged language and sensationalized headlines. Fake news articles rely on fear, anger, or outrage to grab attention. Automated bots and fake social media accounts amplify the spread of fake news. Bots create the false impression of widespread support or popularity. The scale of the fake news problem is a significant challenge. Traditional fact-checking methods cannot handle the volume of data. We need scalable solutions to keep pace with online information dissemination. Automated detection systems are essential. AI and machine learning can analyze vast amounts of data and flag false content. These systems identify patterns common to fake news articles. They also analyze the spread of information online. Automated systems assist in the fight against fake news but are not perfect. Detecting fake news requires cross-referencing information from various sources. A detection system might analyze the text, metadata, and context of an article. This process is complex and requires different analytical techniques. Text analysis identifies inconsistencies or emotional cues. Metadata analysis checks for suspicious website patterns. The information landscape is dynamic and constantly evolving. New websites and disinformation tactics emerge regularly. Detection systems must be adaptable and capable of learning from new data. AI and natural language processing face limitations in detecting fake news. Capturing context and intent is challenging for algorithms. AI struggles with satire, humor, or opinion. Disinformation relies on manipulating emotions and cognitive biases. Fake news creators exploit existing beliefs and trigger strong emotional responses. Language constantly evolves, posing a challenge for detection systems. Disinformation actors use new slang, coded language, or visual cues. Detection systems require ongoing retraining and adaptation. The volume of online information presents a hurdle for fake news detection. Automated systems must be scalable and adaptable. Scalability handles increasing data without compromising performance. Detection systems need robust computational infrastructure. Adaptability is crucial as disinformation tactics evolve. Detection systems must learn from new data and identify emerging trends. Effective solutions must operate across different languages and platforms. Cross-lingual capabilities and cultural understanding are essential. Manual fact-checking remains essential in the fight against disinformation. Human fact-checkers bring nuance, context, and critical thinking. They spot subtle cues of deception and understand language nuances. Experienced fact-checkers scrutinize sources and evaluate credibility. They handle complex cases where algorithms struggle. Human judgment is crucial for navigating grey areas. The human element brings accountability and transparency. Trust in human fact-checkers is crucial for combating disinformation. Technology plays a vital role in addressing online disinformation. Automated systems process vast amounts of data and identify patterns. They crawl the web, scan social media, and process news articles. Algorithms identify patterns and anomalies that humans might miss. AI tracks the spread of content and identifies coordinated disinformation campaigns. Automated systems cross-reference information from multiple sources. They highlight inconsistencies or contradictions. AI provides valuable insights for human fact-checkers. A balanced approach leverages both manual and automated fact-checking. Hybrid models combine automated analysis with human judgment. AI systems screen and flag potentially false content. Human fact-checkers verify accuracy and provide context. This collaborative approach leverages the strengths of both methods. AI handles data processing, while humans provide critical thinking. The hybrid approach improves accuracy and efficiency over time. Continuous improvement leads to more robust detection systems. In the battle against fake news, neither manual nor automated approaches suffice. Manual fact-checking is slow, while automated systems lack nuanced judgment. The solution is synergy, hybrid models combining both strengths. These models leverage AI's speed and human expertise. This ensures accuracy and ethical considerations. Section 2. Technical building blocks. Hybrid models for fake news detection rely on a sophisticated interplay of technologies. Machine learning algorithms form the backbone, enabling systems to learn from data. Natural language processing analyzes textual content and identifies patterns. Image and video analysis techniques address multimedia disinformation. Blockchain enhances trust and transparency in combating fake news. Section 3. Layered algorithmic workflows. Effective hybrid models use layered algorithms for fake news detection, enhancing accuracy and minimizing errors. Each layer evaluates content from different angles, reducing false positives and negatives. Initial layers scan for keywords and stylistic elements. Further layers use NLP and metadata analysis for deeper insights. Combining these layers creates a robust system for detecting fake news. Algorithmic accuracy and bias. Ensuring fairness in fake news detection is challenging. Algorithmic bias can favor certain content based on training data. Diverse data sets and regular audits are crucial to mitigate bias and ensure accuracy. Transparency in decision-making builds trust and accountability. Clear explanations help users understand flagged content. Section 2. Data protection and privacy. Fake news detection systems rely on user data analysis, raising privacy concerns. Developers must prioritize data protection and user privacy. Data minimization is crucial, collecting only necessary data. Transparency and user consent are essential. Robust security measures protect user data. Prioritizing privacy builds user trust. Section 3. System resilience and media literacy. Developing robust fake news detection systems requires more than just sophisticated algorithms. It also necessitates building system resilience and empowering users through media literacy initiatives. Disinformation actors are constantly adapting their methods. Developers must build adaptable and resilient systems. This includes retraining algorithms with new data. Incorporating feedback from human fact-checkers is crucial. Technology alone cannot solve fake news. Empowering users to critically evaluate information is essential. Developers should design transparent user interfaces. Explaining why content was flagged helps users verify information. Collaborating with educators promotes critical thinking skills. Integrating media literacy into detection systems is key. Developers can help create a more informed public. Section 1. Navigating legal frameworks. Developers must navigate complex legal landscapes like the GDPR and DSA, ensuring data protection, transparency, and responsible use of technology. The GDPR emphasizes data minimization, user consent, and security, while the DSA focuses on content moderation and transparency. Developers must ensure compliance with these regulations to protect user data and uphold freedom of expression. Engaging with legal experts and staying informed on policy developments is crucial. Transparency and user consent are cornerstones of ethical and legally compliant fake news detection systems. Users must know how their data is used and have recourse if their rights are infringed. Developers should build transparent systems and provide clear privacy policies. Transparency includes explaining the algorithm's decision-making process. User consent must be explicit, informed, and easily revocable. Balancing disinformation control with individual rights is crucial. Fake news detection systems must avoid stifling legitimate speech or impacting marginalized communities. Defining fake news is challenging as it includes deliberate fabrications, satire, and opinions. Clear criteria and awareness of algorithmic bias are essential to avoid silencing important voices. Collaboration among developers, policymakers, and civil society is key. The fight against fake news transcends disciplines. It requires experts from various fields, each bringing unique perspectives. Interdisciplinary collaboration is essential for holistic solutions. Computer scientists and engineers develop detection systems, but technical expertise alone isn't enough. Social scientists and media experts provide crucial insights. Legal scholars and ethicists ensure responsible solutions. They guide on data protection and freedom of expression. Their input navigates the legal and ethical landscape. Creating collaborative spaces is crucial. Interdisciplinary projects foster innovation and ethical solutions. Breaking down silos leads to robust solutions. Section 2. Advancing data and benchmarking standards. The effectiveness of fake news detection systems hinges on the quality of the data used to train and evaluate them. Standardized, high-quality datasets are crucial for accurate disinformation detection. Existing datasets often suffer from limitations such as being too small, outdated, or skewed towards specific types of fake news or sources. This can lead to biased algorithms that perform poorly on real-world data or disproportionately target certain types of content or communities. Diverse representative datasets are needed to overcome these limitations. These datasets should encompass a wide range of fake news types, including satire, humor, manipulated content, and fabricated news articles, as well as legitimate news from a variety of sources. They should also represent different languages, cultures, and geopolitical contexts to ensure that detection systems are effective across diverse online populations. Furthermore, establishing clear benchmarking standards is crucial for evaluating the performance of different detection systems and fostering transparency and accountability. Standardized evaluation metrics can help researchers and developers compare the accuracy, efficiency, and potential biases of different algorithms, enabling them to identify best practices and drive further innovation. Section 3. Empowering users through media literacy. Technological solutions alone can't combat fake news. Media literacy empowers users to critically evaluate information and identify misinformation. Modern initiatives teach about disinformation tactics, bots, and misleading visuals. Integrating media literacy into education and public awareness campaigns is essential. Empowering users creates a more informed and resilient online community. Section 1. The urgency of a multifaceted approach. The digital age has ushered in unprecedented interconnectedness, enabling rapid information flow. This creates opportunities but also spreads fake news, threatening trust and truth. Addressing this requires a multifaceted approach beyond technology. AI and data analytics help detect fake news. Hybrid models combining AI and human judgment are promising. Technologies must be responsibly developed. Ethical considerations and rights protection are crucial. Technology is just one piece of the puzzle. Empowering critical consumers is essential. Media literacy helps individuals navigate and identify misinformation. Section 2. Towards a future of trust and resilience. The fight against fake news is a societal imperative. It demands collective effort from developers, policymakers, educators, journalists, and individuals. By fostering collaboration and promoting transparency, we can create a future where trust prevails over deception. Developers must build systems that are accurate, fair, and transparent. This includes prioritizing diversity, mitigating bias, and respecting privacy. Adhering to ethical principles ensures technology contributes to a healthy information ecosystem. Policymakers must establish legal frameworks to combat disinformation while protecting rights. Clear guidelines for content moderation and platform governance are essential. International cooperation is crucial for addressing disinformation. Educators empower individuals to become critical consumers of information. Media literacy principles should be integrated into educational curricula. The fight against fake news is a shared responsibility. By working together and demanding transparency, we can build a trustworthy information ecosystem.